So today's lesson is going to be on how to name and write ionic compounds when a particle diagram, when a polyatomic ion is involved. And we're going to learn this through the use of what we call a particle diagram. So what is a particle diagram? A particle diagram is a pictorial representation of what a substance looks like if we were to able to zoom in on it real close. And we're going to be using particle diagrams throughout this course. Now, when you get to your independent practice, your particle diagram may look a little different than mine, and that is okay. Why is that? If a particle diagram is a pictorial representation, let's say I ask the entire class to draw me a picture of a dog. So you all draw a picture of a dog, but does anybody's picture look the same as their neighbor's? Probably not. Chances are everybody's picture looks different than their neighbor's. However, you guys all followed the instructions and you did draw a picture of a dog. So you followed the instructions, you did it correctly, but it's not going to be identical as everybody else's in the class. So let's start with a review of binary ionic compounds, meaning two different elements. All right, magnesium is a 2+ and chloride is a 1-. And we learned that when we write an ionic compound, we swap and drop. So my 1 from chlorine swaps over and down behind the magnesium. And my 2 from the magnesium swaps over and down behind the chlorine. So if this does not make sense to you, then you need to go back and watch my video on ionic naming. All right, what does this mean? I have 1 magnesium, which is a 2+, and I have 2 chlorides, each which have a negative. Now, we know that opposite charges attract. So I have a negative attracted to the positive and a negative attracted to the positive. You should not draw your particle diagram like this, for example, because here you have 2 negatives side by side, and we know that like charges repel. So that is not going to happen. So when you draw your particle diagram, you want to draw it such that your positives and negatives are attracting. And we would name this MgCl2 would be named magnesium chloride. All right, K+ and Br-. So K+, we could just write a plus, and Br-, let's draw us a minus. Now this is representing the ion potassium and the ion bromine or bromide. Notice chloride, my drawing here looks very similar. We're representing these these ions as their oxidation numbers. All right, so when I swap and drop K and Br, I just get KBr. Now these two values that both are a 1, potassium is a 1+. So when the numbers are the same, you just write the formula. You can swap and drop and swap the 1 over and the 1 over, reduce it down. But I ultimately would say if they're the same number, just rewrite your symbols. So what does that mean? That means I have 1 positively charged calcium cation attracted to a negatively charged bromide. And how would we name this? Well, we would name it potassium bromide. Now, what about when a polyatomic ion is involved? And here we go. That's where we get a little bit more tricky. All right, so looking here, CrO4, this is chromate. In this particle diagram, I have 1 shaded circle and I have 4 unshaded circles. So let's look at our polyatomic ion. I have 1 chromine and 4 oxygens. So my unshaded circles are representing the 4 oxygens, and my shaded circle is representing the chromium. Now I've put a dotted line around it with its 2 minus inside. When I swap and drop this, I get Na2CrO4. So what does that mean? That means I have 2 sodium ions and I have 1 chromate ion. So what would happen? My chromate ion, I'm going to redraw it. And I'm going to draw it such that my positively charged sodiums are attracted 1 on each side. Now, you could have put the positively charged sodiums on the top and the bottom. That would have been okay as well, as long as they are attracted 1 on each side. And we would name this sodium. Now, how do we name with the polyatomic ion? That gets a little bit where we have to look into a rule, a little different. When we were naming binary compounds, the second element always became "ide." So chlorine became chloride. Bromine became bromide. When a polyatomic ion is involved, you name it just as the name of the polyatomic ion is. You do not change anything. So CrO4 is chromate. Now, one additional thing. Let's say I had, and I'll just put it down here, aluminum and chromate. Now, when I swap and drop, I end up with 2 aluminums, but I have CrO4, let's write that polyatomic ion, I have 3 of them. When a polyatomic ion appears in a formula and there is more than 1, you will put a parenthesis around it. The 3 swaps down behind the entire polyatomic ion. You cannot change the polyatomic ion. You cannot write Al2CrO4 3, because what have you done here? You've said oxygen has 43. There's 43 oxygens. There are not 43 oxygens. 4 times 3 is 12. There are 12 oxygens. So you must put a parenthesis around a polyatomic ion if more than 1 appears. When the polyatomic ion only appears as a singleton, just 1, no parenthesis. Please be careful with the parentheses.